Hi everybody. Today we shall discuss what is meant by a linear time invariant system. So before going into the topic, we must know what is meant by a system. A system is a device which applies some kind of transformation to the input signal applied, and it produces output. So the transformation can be represented. The transformation can be represented in the form of mathematical expression. So that is the system. For example, here, so in the equation given here, this x of n, it is the input signal, and that input signal is given to the system. So inside the system, some kind of transformation is taking place. So a system, it should make some transformation to the input signal, and the output signal is produced here. So here the mathematical expression to represent a system is y of n is equal to t of x of n. Y of n is equal to t of x of n. T stands for transformation. So the kind of transformation that is applied to the input signal can be any kind of transformation which can be represented by some mathematical expression. So this is a system. So now we shall move on to a linear system. So what is meant by a linear system? So here, wherever the word linearity comes in signals and system or digital signal processing, we must be very, very aware that it must mandatorily obey superposition principle. So what is meant by superposition principle? It is a kind of addition followed by a specific rules. That kind of addition. So let us look here in this slide. We can clarify that the thing that superposition principle. Okay. So here, consider a system. This is one system, and here to this system we are applying the input signal x1 of n, and some kind of transformation is occurring inside the system, and we are getting the output as y1 of n. Similarly, in the next system, we are giving the input signal x2 of n, and some kind of transformation is occurring inside the system, and we are getting the output as y2 of n. Suppose we weight the input signal. Weight means let us multiply the input signal by some kind of variable, and we are adding the input signals, and then we are considering the entire input signal and giving them as input to the system. So the output should be the same kind of additive that we applied for the input signal. For example, here, so here we are multiplying the input signal x1 of n by a variable a and x2 of n by a variable b, and we are adding them both. We are performing some kind of additive rule to those input signals, to those weighted input signals, and we are passing it to the system, inside the system, and we are getting the output as a y1 of n plus b y2 of n. If we get like this, then this system is called as linear system. So how does this take place? So let us see. Here, as I mentioned earlier, y1 of n is the transformation of x1 of n, y2 of n is the transformation of x2 of n. Similarly, here we are applying the signal a x1 of n plus b x2 of n into the system, and inside the system the transformation is taking place to the entire signal. So the output is a into the weighted value, the factor by which we are weighting the input signal can be taken out, a into transformation on x1 of n plus b into transformation of x2 of n. If we are getting the result like this, then it becomes linear system. Obviously, transformation of x1 of n is y1 of n, and transformation on x2 of n is y2 of n. So that is why in the final equation we are getting a y1 of n plus b y2 of n. So this is regarding linear system. Next we shall discuss about a time invariant system. So what is meant by a time invariant system? So here, time invariant system is a system that is not affected by time. So any change in time to the input signal does not affect the output of the signal. So that kind of system is called as time invariant system. For example, here let us consider a system. So this is the general representation of a system. X of n is the input signal to the system, and some transformation is occurring on the input signal inside the system, and we are getting the output as y of n. Suppose we are shifting the input signal by some k units. We are shifting the input signal by some k units, and then we are applying the signal inside the system. So the transformation that is occurring on the time shifted input signal make the output signal also shifted by time by same units, y of n minus k. So when we apply x of n minus k, we should get y of n minus k. When we apply x of n plus k, we must get y of n plus k. So if we get this kind of output for the time shifted input signal, then that kind of system is called as time invariant system. So linear time invariant system, they play a vital role in signals and system and digital signal processing because they have certain fundamental property which are highly useful for the analysis of signals. So we shall discuss them in the upcoming videos. Thank you for watching. Thank you.